When a cricket ball leaves the hand of an elite fast bowler, it can reach speeds of 145 kilometers per hour. Over the 20-meter distance of the pitch, a delivery moving at that velocity gives the batsman exactly 0.44 seconds to react. This chart shows the sequence of human processing crammed into that sub-half-second window. The batter must perceive the release point, decide if the ball is swinging or bouncing, and physically maneuver a heavy wooden bat into the correct intercept position. An isolated human shoulder joint simply lacks the muscle mass to generate this kind of speed, let alone impart the spin required to make the ball deviate in the air. To bypass the limitations of a single arm, a pace bowler has to recruit their entire anatomy, sequencing a highly intricate chain of movements to manufacture and release explosive kinetic energy. The generation of energy begins before the bowler reaches the crease. A smooth, accelerating run-up builds initial linear momentum, creating a baseline of kinetic force. At the delivery stride, the bowler's back foot absorbs vertical ground reaction forces up to 2.9 times their body weight. This massive force channels upward as the spine extends upon landing, then violently flexes forward, acting as a whip-like lever carrying energy through the torso. By planting a rigid front leg, the bowler slams the brakes on their forward momentum, converting linear speed into rotational torque. The torso snaps, funneling torque into the shoulder. The arm whips over the top, drastically accelerating until the ball leaves the fingers. By perfectly timing these segments, the body functions like a multi-stage rocket, maximizing the payload of kinetic energy delivered into the cricket ball. Once the ball is airborne, the physics shift from biomechanics to fluid dynamics. As the spear travels, it forces the surrounding air to negotiate a path around it, creating a thin skin of air known as the boundary layer. A cricket ball has a specific physical trait allowing bowlers to manipulate this boundary layer, a tightly wound, raised leather seam running directly down its center. This wind tunnel image shows the ball released with the seam angled at 45 degrees. The raised stitching trips the air, causing turbulence on one side. Meanwhile, the opposite side remains undisturbed, or laminar, which loses velocity quicker and separates from the ball much earlier. This imbalance means turbulent air wraps further around the back, skewing the aerodynamic wake toward the smooth side. By Newton's third law, this skewed wake pushing air one way applies a counterforce, pushing the ball in the opposite direction, right where the seam is aimed. A ball curving sharply through the air relies entirely on the precise, deliberate manipulation of these aerodynamic properties to deceive the batter. Yet generating extreme speeds and late aerodynamic deviations is only effective if the delivery is aimed at a specific vulnerability. A bowler has to constantly scan the batter's stance, footwork, and bat grip to detect weaknesses. They use this real-time data to select the right variation, deciding whether to drop in a disguised slower ball or a toe-crushing Yorker. This diagram illustrates how those deliveries dictate field placement. The bowler and captain position fielders like chess pieces, setting physical traps in the exact zones where an outswinging delivery is most likely to induce a false shot. Executing these plans over a long spell requires intense emotional control. Even when facing an aggressive batter who is actively trying to disrupt their rhythm, the bowler must maintain total focus on their target line and length. They also have to factor in the environment. As the grass on the pitch wears down over the course of a match, or if humidity levels shift, the bowler must adjust their grip and release points to compensate. The athletes hurtling down the pitch are running a continuous calculation. They coordinate high-level biomechanics, exploit complex fluid dynamics, and make split-second tactical decisions to dismantle the opposition.